Okay, so today we're going to be talking about standard form, the third type of equation that we need to look at. But before we go into that, we need to finish up the warm-up for point-slope form. So remember that point-slope form is an equation of, let's see if I can get this right, y minus y equaling m times x minus x. So in the first problem, I'm going to do the first one over here. We need to find m, we need to find our slope. So m equals -7 minus a -1 over 6 minus a -4. When you go plus the opposite, that's going to end up giving me -6 over 10, which will reduce down to -3 over 5. Having a difficult time writing today. -3 over 5. So now all you're going to do is plug that into the equation. And you have two different equations you can get. You can have y plus 1 equaling -3 over 5 times x plus 4. Or you can have y plus 7 equaling -3 over 5 times x minus 6. Both of those will end up working the same and giving you the same graph. It just has different starting points. So that's problem 1. Problem 2, same thing. I need to find my slope. So m equals 5 minus -5 over 4 minus -4. It's going to give me 10 over 8, or positive 5/4. Again, plugging into the equation, you could have y minus 5 equaling 5 over 4 times x minus 4, or y plus 5 equaling 5 over 4 times x plus 4. Number 3, same thing again. Find our slope. So 36 minus a -20 over 4 minus a -3. That gives me 56 over 7, which reduces down to 8. So my one equation could be y plus 20 equals 8 times x plus 3, or y minus 36 equals 8 times x minus 4. And either one of those would be perfectly correct. So as I mentioned earlier, today we're going to be looking at standard form, and we're just going to kind of work our way through. So we're going to start by talking about equivalent equations. And basically all equivalent equations is they have the same basic features, and we're either multiplying everything by the same number to get it to grow larger, or you could also divide everything by the same number in order to get your equation to go smaller. So here's my base equation, 2x minus 6y equals 4. I can make an equivalent equation by multiplying this equation by 3. And that would give me 6x plus -18y equaling 12. This is an equivalent equation. All I did was multiply everything by 3, or make the entire equation grow by 3. You can also do the opposite, starting with my base equation. I can also divide everything by 2. And that would give me 1x plus -3y equaling 2. This is also an equivalent equation. And you can multiply or divide by any number that you would like. I would suggest dividing by something that's going to divide evenly into everything. For instance, if you look at problem 2, I would not try and divide problem number 2. There's nothing that's evenly going to divide with 1s and 3s. So in problem 2, I would just take two numbers, any two numbers you can think of, positive or negative, and multiply the entire equation through by that. So go ahead, try that on your own. So again, everybody could have different answers, but just two that I came up with. I multiplied the equation through by 3, so I got 3x plus negative 3y equaling 9. I also chose to multiply the equation through by 4. So 4x plus negative 4y equals 12. And again, your answers could be different than your neighbors depending on the values that you picked. But in the end, that base equation should remain the same. So now we're going to look at writing an equation in standard form. In order to write an equation in standard form, you want to start in point-slope form. Okay? You want to start in point-slope form, write it in standard. Standard form is ax plus by equals c, where a, b, and c are just numbers. A, b, and c don't represent the slope, they don't represent the y-intercept, they don't represent a point, they're just numbers. And basically we can get there by solving down through a point-slope equation. So, starting with the first one, you want to write this in point-slope form first. So that's going to give me y minus 2 equaling 1 times x plus 3. That's the equation in point-slope form. Now what you want to do is you want to distribute through the parentheses. I know we're just distributing at a 1, but at some point you won't be distributing a 1, so you want to distribute through. So y minus 2 equals 1x plus 3. The format says I need to get everything with the x and the y over on the left-hand side, and I need to get all of my constants, or the pieces without the variable, over to the right-hand side. So I'm going to add negative 1x to each side. So now I have negative 1x plus 1y minus 2 equaling 3. I'm almost there. I'm now going to add 2 to each side. And I end up with negative 1x plus 1y equaling 5. And this equation is now in standard form. So all it is taking an equation in point-slope form and kind of distributing and moving pieces around until we get it to look like we want. Looking at another one just so you can see it. So this would be y, my pen doesn't want to work, y plus 1 equaling 3 times x minus 4. Distribute through the parentheses, so y plus 1 equals 3x plus negative 12. I'm going to add negative 3x to each side. And that's going to give me negative 3x plus 1y plus 1 equaling negative 12. Add 1 to each side. Final answer in standard form, negative 3x plus 1y equals negative 11. You're going to notice that 9 times out of 10, your y value is going to be 1 or a version of negative 1. And the way we can get equations in standard form that don't have that 1 there is to change these into equivalent equations, to multiply the entire equation through by 4. Or by negative 2. I'd like you to go ahead and try these two on your own, and then we'll come back and I'll go over them so you can see how it works. Now that you've had a chance to try them on your own, you're going to start with point-slope form, so y minus 5. So y minus 5 equals negative 2 times x minus 0. distribute through the parentheses, so plus negative 5 equals negative 2x plus 0. Add 2x to each side. 2x plus 1y plus negative 5 equals 0. You have to keep the 0 there. We have to keep something on each side of our equal sign. So our final answer for the first one is 2x plus 1y equals 5. Looking at the second problem, we are looking at y plus 4 equaling 3 over 2 times x plus 4. Y plus 4 equals 3 over 2x plus 6. I'm going to add negative 3 over 2 to each side. Do not change that into a decimal. That's going to give me negative 3 over 2x plus 1y plus 4 equaling 6. Add negative 4 to each side. Negative 3 over 2x plus 1y equals 2. And that's our final equation in standard form. So now we're going to look at how do we write an equation in standard form from a graph. Basically what you would need to do from the graph is you need to take two ordered pairs. And again, using those two ordered pairs, we're going to write it in point-slope form, and then from point-slope form, we'll change it over to standard form. So in order to write this in point-slope form, I have to have the slope. So negative 2 minus 1 over 2 minus 1. That's negative. Did I write that wrong? So that's negative 3 over 1. Put that into point-slope form. You can pick either of the 2 points. Either way, you'll get the same answer in standard form. I'm going to choose the 1, 1 because it's smaller numbers and I don't have the negatives. So y minus 1 equals negative 3 times x minus 1. Distribute through the parentheses. Y minus 1 equals negative 3x plus 3. I'm going to add 3x to each side. So 3x plus 1y plus negative 1 equals 3. Add 1 to each side to get my constants together. 3x plus 1y equals 4. So it's the same thing we were just doing. You just have the extra step of finding the slope first. Looking at number 2, we're going to find our slope. It's going to be negative 3 minus a negative 1 over 2 minus 3. That's going to give me negative 2 over negative 1, or a slope of 2. Plugging that in point-slope form. Again, pick either ordered pair. I'm going to use the 2 and the negative 3 this time just to change it up a little bit, but it honestly doesn't matter. So y plus 3 equals 2 times x minus 2. Distribute through the parentheses, and I get y plus 3 equaling 2x plus negative 4. Add negative 2x to each side. Negative 2x plus 1y plus 3 equals negative 4. Add negative 3 to each side. You end up with a final answer of negative 2x plus 1y equaling negative 7. And that's your final answer in standard form. So what we're going to do here, again, I want you to try these two problems on your own. You need to get your slope, put it in point-slope form, and then go on from there. And then we'll come back and we'll go over them. So now that you've had a chance to look at them, we're going to go through together just so you can see it. So I'm going to find my slope. Negative 2 minus 2 over 4 minus 2. That gives me negative 4 over 2, or negative 2 as my slope. Plugging that in, y minus 2 equals negative 2 times x minus 2. Y minus 2 equals I'm going to add 2x to each side. And I get 2x plus 1y plus negative 2 equaling 4. I'm going to add 2 to each side. 2x plus 1y equals 6. Second one, again I'm going to find my slope. 4 minus a negative 4 over negative 8 minus 4. That's going to give me 8 over negative 12, or negative 2/3. Plugging that in, y plus 4 equals negative 2/3 times x minus 4. Y plus 4 equals negative 2/3 x plus 8 over 3. Don't get all caught up in the fractions right now. So I'm going to add 2/3 x to each side. 2 over 3x plus 1y plus 4 equals 8 over 3. Add negative 4 to each side. I need to get a common denominator. To change negative 4 into having a common denominator of 3, I need to multiply the negative 4 by 3, giving me negative 12 over 3. And I'm thinking, yeah, my 2/3 shouldn't be negative. Sorry, that one was my fault, so it should be a negative 2/3 at the end. And then it should be a negative 8/3. And then that will give me a final answer of negative 2 over 3x plus 1y equaling negative 20 over 3. If you would like to get rid of the fraction, at this point you could get rid of the fraction by multiplying everything through by 3, making one of those equivalent equations again. And if I did that, I would get negative 2x plus 3y equaling negative 20. It would clear out that fraction. You don't have to do that. You most certainly can leave it as the fraction. But if you really don't like fractions, you could certainly get rid of them that way. We're going to skip example 4 for right now. So we're just going to move on from the next 2 slides. We're going to skip the homework because we're going to skip the next warm-up because we're just. So I believe that was 4 slides now you should have crossed out on your handout. But now we're going to hop up over here with a new example 4. Here we're going to complete an equation in standard form. Basically what's happening is you already have the equation in standard form, but you need to find this missing variable. Notice the a here. We have to figure out what that a is. In order to do that, you have to be given an ordered pair. And in the ordered pair, you have an x and you have a y. So basically, all we're going to do is we're going to plug the x and the y into the equation and solve for the variable that we're missing. Whether we're missing a, b, or c, it doesn't matter. So what this would look like then is a times negative 1 plus 2 times 0 is going to equal 2. Negative 1a plus 0 equals 2. The 0 technically goes away, and I have negative 1a equaling 2. Divide each side by negative 1, and a equals negative 2. You do need to write the final equation then, so negative 2x plus 2y equals 2. All you're doing is plugging the x and the y in, solving for the missing piece, and then writing the final equation. I'd like you to go ahead and try these 4, and then we'll come back together and go over them. Now that you've had a chance to go over them, we'll go over them together. In the first one, we're missing b. So negative 4 times negative 1 plus b times 1 needs to give me 7. 4 plus 1b needs to give me 7. Add negative 4 to each side. And I find that 1b equals 3. So my new equation for this one is going to be negative 4x plus 3y equals 7. For the second one, a times 2 plus 11 needs to give me negative 3. 2a plus 11 needs to give me negative 3. Add negative 11 to each side. And you get 2a equaling negative 14. Divide each side by 2, and we get a being negative 7. So negative 7x plus 1y, or just y, equals negative 3. Number 3, a times 2 plus 3 times negative 1 needs to give me 5. 2a plus negative 3 needs to give me 5. Add 3 to each side. 2a equals 8. Divide each side by 2. a equals 4. 4x plus 3y equals 5. Last one. Negative 1 times negative 2 plus b times negative 2 needs to give me 10. 2 plus negative 2b needs to give me 10. I'm going to add negative 2 to each side. Negative 2b equals 8. Divide each side by negative 2. And you get b equaling negative 4. Final answer, negative x plus negative 4y equals 10. Last example, everyone's favorite, a nice word problem. So this is the new example 5. Basically, we're just going to work our way through it. We have 2 things we need to answer. We need to write an equation, and then we need to list some combinations. So our class is taking a trip to the public library. You can travel in small and large vans. A small van holds 8 people. A large van holds 12 people. You could fill 15 small vans, and you could fill 2 large vans. So from here, we want to go about and we want to figure out how we're going to write an equation in standard form. And basically, what we're going to do is 8 people in however many small vans I need, plus 12 people in however many small vans I need, needs to get me my total. Well, to figure out my total, I need to do the 8 times the 15. Oh, wait, I'm sorry. Small van holds 8 people, so 8 times the 15. That gives me 120 people in my small vans. 12 people in my large vans. That's 24 people in my large vans. So that's 144 people altogether. That's how you would get the equation. Your total is the total number of people you're taking. You can fit 8 people in the small van. You can fit 12 people in the large van. Several possible combinations. Okay, we know that one combination is 15, 2. That was given to us. Okay, they could take 15 large vans. I keep getting those mixed up. They could take 15 small vans and they could take 2 large vans together. Other possible combinations. Basically, all you're going to do is pick a number for either x or y, it doesn't matter, and then solve for the other one. Anytime I'm asked to give possible combinations, I usually plug 0 in for each variable, and that usually pretty easily gives me my 2 combinations. So if I plug 0 in for x, that's not what I want, so I'm going to plug 0 in for x. That's going to take this piece away, and I end up with 12y equaling 144. Divide each side by 12, and another combination, x was 0, y would be I could just take 12 large vans. Going to do the same thing now, but this time I'm going to make y be 0. So that leaves me with 8x equaling 144. Divide each side by 8, and I figure out that it could be also 16 comma 0. I could just take 16 small vans and not take any large vans. That doesn't seem right to me. Hold on a minute. 144 divided by 8. 18, not 16. I knew that didn't seem right. It should be 18 large vans. So 18 comma 0. Your homework tonight, not in your textbook. What I'd like you to do for your homework tonight is I'd like you to go into your workbook, and I would like you to try page 76 and try 1 through 15 for me. Okay? I'm going to be back tomorrow. We will touch base tomorrow on everything you've had questions on my last 3 days out. But I am expecting to see that you have tried this, as well as having tried the classwork, as well as having tried the word problems. If you can show me you've tried and that you've made an effort, then I'm not going to have any issue. If I come back tomorrow and you stare at me with all sorts of blank papers, then I'm going to have more of an issue. So hopefully this went rather smoothly for you and you were able to follow along in the notes pretty well. I know we did kind of skip around a whole lot. That's because this technically is typically a 2-day lesson, but we're going to do it in one video and then kind of play catch up tomorrow.